Hi everyone, welcome to today's online meetup talk. My name is Ben and I will be your moderator today. Before I introduce you to our speaker, I have a few housekeeping items. Our participants are automatically unmuted throughout the session. We will be using Slack to communicate. Please take a moment to join us on the community Slack channel, and which is copied below in the chat box, alluxio.io/Slack. You should be already received an invitation to this Slack channel. And whenever you have any questions, feel free to leave the question on the Slack channel. We will just come back to you. We want this session to be actually interactive, so feel free to raise your question. If you have any trouble joining Slack, also feel free to message me your question instead, and I will share it with the group. In today's session, I will give a brief presentation and then we will start. Then we can answer your questions too in the Q&A session in the end. To answer the question, join the community Slack channel posted into chat box here, the chat box here, which is alluxio.io/Slack. Please don't hesitate to send your questions anytime. No need to wait until end. Lastly, today's session is being recorded and it will be available for on-demand playback. We will email you the link to the presentations as well. I believe this is all the housekeeping items. So let's just start. Today we have three speakers, Jennie Wang from Intel, Louie Tsai from Intel, and also me from Alluxio. And today's topic is talking about how to use Analytics Zoo and also Alluxio as a stack to enable fast deep learning in a hybrid cloud environment. Today's presentation has three parts. We will first start talking about deep learning and also what is Analytics Zoo, the overview of Analytics Zoo, followed by the challenges in a hybrid environment for deep learning. And we will propose architecture to use Analytics Zoo with Alluxio. And third part, Louie will present the experiment results about our benchmarking to show you the power. Without further ado, I will introduce the first speaker, Jennie, who will present the first part.
Hello, everybody. Welcome to this meetup. I'm Jennie Wang from the Intel MLP Machine Learning Solution team, and I'm focused on the development the deep learning and the machine learning frameworks on the big data systems. Okay, next slide. So I think everybody will notice that deep learning grows very fast in the recent years, and we can see it in this diagram. With the you can see with the amount of data grows a huge amount. A large neural network or machine learning models can gain a better performance. So that shows that the deep learning application or program is data driven, and also it needs to access a huge amount of data. And the next slide. So because we noticed there has every day, almost every month, there will come a very new models and algorithms in the deep learning communities, and but in the industry, in the production environment, the people like the big data engineering or the data scientists in the production environment, they are eager to apply the deep learning or machine learning algorithm and models to their existing data flows and on the existing big data systems. But integration the machine learning, deep learning system is not very easy. You can see in this diagram, the big data analytics pipeline is a complex system. The machine learning or deep learning code is just a very small black box in the system. And in this big data analytics pipelines, you also need a lot of components like the data collection, feature extraction, machine resource management, model serving, infrastructure monitoring, etc. So I think that creates a difficulty for the big data users that how to integrate the machine learning to their existing workflows. So go to next slide. Because this purpose, we create the analytics project, which is an open source project, mainly from the Intel MLP team. And the Analytics Zoo project is is a unified AI analytics framework, which can help the big data users to create the end-to-end deep learning pipelines. Using the Analytics Zoo platform, the users can create a prototype on their laptop with just small sample data, and then they can move the pipeline to the experimental clusters even without any code change and directly on their production data. And after they train the deep learning models and pipelines, they can apply the pipeline and deploy the pipeline to the production environment seamlessly. Next slide. So let's look at what's inside in the Analytics architecture. So you notice in the very bottom of the architecture, the backend can be a various compute environment. You can use laptop, or also you can work on the Analytics can work on the Kubernetes clusters, Hadoop, Spark clusters, and the Analytics can support different deep learning frameworks like the TensorFlow, PyTorch, BigDL, OpenVINO, etc. And it can support a various of distributed analytics platform like the Spark, Flink, Louie. And the user can leverage many Python libraries to do the deep learning, to do the machine learning, like the NumPy, Pandas, sklearn, etc. And on top of the backend, Analytics will provide integrated analytics and AI pipelines. So there are some components. Analytics will provide the distributed TensorFlow and PyTorch support on the Spark. And we also support the Louie on Spark clusters. And we create Spark Dataframe and machine learning pipeline support for the deep learning. And we create the inference model, which can support the multi-thread scalable inference. And on this type pipelines, we create automatic machine learning workflows. The AutoML workflow for the time series prediction is to help the user to do the automatically feature selection, hyperparameter tunings for the time series models. And we also provide the automatic cluster serving service in the Analytics Zoo. And to help the user to make their applications easier, we create a common building models and algorithms, which are focused on the recommendation areas like the NCF wide-ending session recommender, and also for the time series models like the anomaly detection models, and also we provide the building computer vision models like the image classifications, object detections, and some NLP models like the BERT transformer and a text classifier, etc. So let's look at some details of the Analytics Zoo. Next slide. So Alluxio Zoo provides distributed TensorFlow on Spark. So I think this is very convenient for the current TensorFlow users. So users can create their TensorFlow model, just use the TensorFlow syntax or the TensorFlow Keras syntax, and then they can use our TF datasets API to generate the data from their training RDD, and then use the TF optimizer to train the data with the TensorFlow model. And from that way, it can automatically dispatch the TensorFlow workflow on the Spark cluster in parallel. Next slide. And Analytics also provide the Spark Dataframe and machine learning pipeline support for the deep learning. We create the compatible machine learning pipeline APIs you can see in this code snap. We create the estimator, which is compatible with MLlib pipeline. So that helps the user to create a complex analytic system, which can integrate the MLlib pipeline and other Spark workflow. So in this pipeline, you can do the machine learning and deep learning and the other processing together. Next slide. And the Analytics also provides the Ray on Spark framework. And you may also know Ray is one of the hottest distributed computation framework from the RIS lab. And the Ray framework can help the Python users to automatically dispatch their Python code on the distributed environment. And for the existing big data engineering big data users, we created Ray on Spark, which can use the Spark to launch the Ray clusters on the Spark executors and manage the Ray process with the Ray managers on each Spark executors. And then user can create their Ray applications and directly run on the existing Yang and Spark and Kubernetes clusters. Next slide. For the serving, I think it's very important for the real analytics systems. So Analytics will provide a distributed automatic cluster serving architecture. So user can simply start the class serving service on the local node, or they can just running the Docker container, which can deploy the machine learning deep learning models to the specified Hadoop Yang Kubernetes clusters. And what the user do is very simple. They can write a very small Python code, which can they can just put the data in this example. They can put the images to the input queue, and then from the output queue, they can get the prediction result from the cluster serving. So using this cluster serving framework, user do not need to deploy the complex distributed inference solutions by themselves. And it also can support different kind of deep learning models like TensorFlow, PyTorch, Caffe, BigDL, OpenVINO, and it can support different real-time data analytics framework like Spark Streaming and Flink, etc. Next slide. And Analytics Zoo also provides scalable AutoML for time series prediction. So it can support automatic feature selection, model selection, and hyperparameter tunings based on Rayon Spark for the time series models. Next slide. Analytics Zoo, we have collaborated with many companies and partners to help them create their analytics Zoo deep learning pipelines. This is an example of our collaborations with JD.com, which is one of the biggest e-commerce company in China. So in this use case, the target is to extract the object in the image and then extract the features of the targeted image and store the features to the HDFS. So in their original system is that they store the data to the HBase and on the Yang cluster, and then they do the preprocessing with Spark. But their their deep learning model, which is a TensorFlow model, is on the GPU. So they need to move data to the GPU cluster to do the inference, then move data back to the Yang clusters to get a target object image, and then do the preprocessing again with the Spark, and then again move data to the GPU cluster to do the deep bit model inference again, and save data back to the HDFS. So after they adopt the Analytics Zoo to their pipeline system, because Analytics Zoo can load the TensorFlow models to the Spark Yang clusters, so they don't need to do the data transfer between the GPU cluster and the Spark Yang clusters. So the whole workloads can work on the existing Yang cluster. So from this change, their current solution is 3.83 speed up compared with their old GPU solutions. Next slide. So we also have other customer and partners to do the various of use cases. And during our work with our customer and partners, we found there has some challenges for them to do the deep learning applications in the current hybrid cloud environment. So Bing will introduce the challenges in the hybrid cloud for the deep learning. Okay, let's welcome Bing.
Thanks, Jenny. Yeah, so my name's Bin. Before I go to the second part, I want to introduce myself a little bit. I'm Bin Fan from Alluxio. I'm one of the founding members in the Alluxio team. Before I joined Alluxio, I was an engineer in Google working on the next generation large-scale storage system. Before I joined Google, I was doing my PhD in Carnegie Mellon. Yeah, so today I'm talking about Alluxio and how Alluxio helps in the picture in the context of hybrid cloud and in the context of deep learning. So about maybe, I would say like 6 months ago, we started a conversation with Intel team talking about, hey, we know Analytics Zoo is very cool. Can we do something together with Alluxio to solve certain problems we see in hybrid clouds? So that's the beginning for this collaboration. And I will talk first about what kind of challenges we see in the field in the last few years, starting with the trends of deep learning or data intensive applications, and with the trends of adopting cloud. And then I will talk about Alluxio, which is the open source data orchestration layer originated from Berkeley, UC Berkeley. And I will talk about the combined stack, the joint solution using Analytics Zoo with Alluxio. So we'll talk about what we see. Let's talk about this first. What we see in the past few years, the big data the journey for a lot of different enterprises pursuing big data and also machine learning, and also their innovation in this field. About maybe a decade ago, Google published 3 papers about MapReduce, GFS, and Bigtable, and people learned a lot about it, and people invented Hadoop, the entire Hadoop ecosystem. And in this Hadoop ecosystem, a very strong assumption is we're maintaining a monolith data platform with a combined or deeply coupled co-located compute and storage. For example, you run HDFS, and on these nodes, you also run your compute to run MapReduce or Hive jobs or some other like Spark jobs. And mostly people are running this in the same data center. And this was true for at least more than 10 years. Later on, people generally moving to another direction that they realize it's very hard to scale independently in different dimensions about their compute and their storage. So gradually, we see more and more enterprises adopting what we call disaggregated architecture. So they have a pool of resource dedicated for compute and another pool of resource dedicated for storage. And this becomes actually very true, or the default setting for machine learning or deep learning, because a lot of times they require to run this effectively, it requires very different, very specialized hardware, like equipped with a lot of GPUs. That's what we see a lot. So you don't want to store a massive amount of data on these very heavy GPU heavy machines because they are very expensive. So yeah, we see a discrete architecture with a separate compute and storage. Later on, we see more and more advanced around this direction. For example, they may even pursue burst their workloads, their machine learning workload, their analytics workloads into public or private clouds. And this brings us several benefits, including make the effort very elastic. So whenever you have very bursty demands in your compute power, you can always utilize the public cloud to satisfy your needs. But also, it creates some challenges we will talk about in the next slides. And we also see a lot of companies are pursuing the approach to run multiple different data centers around different regions or in different parts of the world to improve their locality. So in this case, we see more and more challenges in how we can enable fast data acceleration across different data centers. So one company we see, like a lot of users like this in this company we see, is they are running multiple different offices around the world, but they want to have a centralized data repository with collected training data, things like this. But in different offices, they also want to run machine learning jobs accessing the same source of truth. So in this case, it's very challenging to guarantee you get a very efficient data transfer across different regions. I will talk about this challenge in the next slide with more details. So essentially what we see is more and more data are getting increasingly remote from the compute. And this is driven by multiple different factors. Data-driven initiatives needs more and elastic compute power. So different companies, enterprises are pursuing cloud as one of the solutions to provide a temporarily available computing power. And also people are running more and more Hadoop systems, but in a remote way, they're launching different data centers. And another interesting trend we see in the field is the object store is getting dominating, at least in the cloud region. And like, for example, the AWS, the very famous AWS S3 service is based on object storage. And it's separated from where you run even in the same AWS region because it's a separate service. Then the next natural challenge is how to make the remote data local to the compute without copies. If you are running very data intensive applications like machine learning or deep learning, you don't want to always copy data around. That's very expensive and that's time consuming. And also you have to spend manpower to do data curation, to clean the local storage, which is very like people don't want to do this as a dirty work and can create a lot of DevOps debt. So if we can solve this problem, it brings several business benefits, including you can get faster data-driven insights, so you can always access data from a very remote place without doing any data ETL or data copy. And you can utilize the elastic computing power to solve problems quicker. Like for example, if Fed changed the rate, right, the interest rate, you always want to recompute your model, and that requires maybe a lot of computing power in a very short amount of time. And then you can utilize the resource in public cloud for this demand and to train your models. And also, if you can do this efficiently, you want to reduce your egress costs. You don't want to always copy data from cloud to some other places because cloud providers will charge you on top of that. So that's what we're building. That's Alluxio. The solution for Alluxio is something called zero copy bursting. So you can easily scale your applications to the cloud. Two typical scenarios we see in the field. One is you run applications like Analytics Zoo on top of Alluxio and connect it to S3. So you can accelerate the big data or machine learning frameworks in the same public cloud. Or the other scenario we also see for maybe more on the bigger and more established enterprises is they're looking for the solution to burst their data into cloud, but the data is stored in the HDFS. As I show on the right-hand side, put the data in the HDFS on-premise data center, but burst the data into the cloud running, for example, Analytics Zoo. So this is basically what we're proposing here. And if you are not familiar with Alluxio, it's a distributed data orchestration layer. It's originated as a research project called Tachyon from UC Berkeley MLab as the PhD thesis for the student Haoyuan Li. Alluxio is the open source project established in 2015, and there's a company, the company I'm working in, to commercialize this Alluxio project. So we are behind the top VCs, including Andreessen Horowitz in the Silicon Valley. Alluxio is the data open source data orchestration layer. As you can see, it's not a compute, it's not a storage. Instead, it's a middle layer in this data stack. You can run different applications on top of Alluxio, and you can connect Alluxio to different, we call physical or persistent data stores and in the bottom, including S3, including Azure, including HDFS or some other storage services provided by different vendors. So the benefits of having Alluxio here provides benefits in multiple fold. It can provide some ability to users to set different data policies. For example, I want to cache this data, or I want to set a TTR for this data. I want to do some data transformation around this data. So the data closer to the compute can be different from what is stored in the physical store. Different in the meaning, it's you just only cache the hot part of the data, or you only you transform data into certain form, easier and more friendly to be consumed. So Alluxio is largely used in the analytics world. Previously, Alluxio is used a lot in analytics workloads by, for example, Spark or Presto. And recently, we see more and more use cases around machine learning. And the collaboration with Intel using Zoo and Analytics Zoo is one of the examples. So I want to have one slide to explain why Alluxio can help, especially when the data is remote. One of the key observation is when you bring the data closer to the application, it can provide a lot of speed up. For example, if the data is in memory, as I showed on the left-hand side, and local to Spark, and you can provide per node like 10 to the power of like 10,000 or 100,000 megabytes per second. That's very fast. Or even you have we don't have enough memory, or you can put SSD to hold more data. still you have the power of having data transfer to applications at the speed of 1,000 to 10,000 megabytes per second. In contrast, if you have data stored in a different region of the world, and this is, for example, in a different region of the Hadoop cluster, and the transfer can be slow, but this can be only required when necessary. So we only transfer data across the wire when it's necessary. And at that time, the bandwidth is much lower. It's about like typically we see 10 to maybe 1 gigabytes per second, 10 megabytes to 1 gigabytes per second. That's the typical rate we see if you transfer data around into like cloud. So by having data cached in Alluxio space closer to applications, you provide a much faster I/O, but also being intelligent about what data to access. Cached data you have already accessed or you are repeatedly accessing, you can significantly reduce the time used to require to access data remote. So that's basically the key takeaway from the solution zero copy burst. Okay, so next part, I will handle this to Louie, who will talk about the benchmark about using Analytics Zoo with Alluxio, talking with different using remote object store. Hey, Louie.
Yeah, thanks, Bing and Jennie. So as you know, we have lots of benefits from Analytics Zoo and Alluxio. We want to show you some performance number, combine those two solutions. So in this case, we're using AWS EC2 instance type, R5 a large instance type to do our experiment. And we're using 32 vCPU inside the instance, and we have a 506 gigabyte memory. And next slide. So overall, we use 6 R5 8 large instance. So one worker per instance. As you can see in the left-hand side, diagram, we have 6 worker nodes inside our cluster, and we're using Analytics Zoo inception model on ImageNet as our application, and we're using training. And then once you launch the application, you can see there's 6 executor inside our cluster. Next slide. So along the application timeline, first there's a data loading part, and then come to the deep learning computation part. So for data loading part, we have 2 main jobs. The first job 0, is loading training data set. And the second job 1, is loading testing data set. So basically, we will measure the time difference, the latency for job 0 and job 1, and we will test among different scenarios using Alluxio without using Alluxio. So for job 1, actually there are 2 stages. First stage is stage 0 and stage 1. So we will mention about the difference between our experiment on stage 0 and job 1. We also contain stage 2 and stage 3. So next slide. So we are doing 2 different experiments. First, we're using S3 data. We measure the job 1 and job 0 time. And second experiment, we're using Alluxio, and we also measure the job 1 and job 0. As you can see inside the stage 0 and stage 2, because when we use the S3, as you can see, we are accessing the S3 directly from Analytics Zoo ImageNet dataset. And another experiment, we're using Alluxio data. As you can see, we're accessing the data from Alluxio master node, So that's the two different experiments we conduct for this performance analysis. Next slide. So in the left-hand side, here's a performance evaluation diagram. For the light blue one is with Alluxio. The yellow one is without Alluxio. The y-axis is average loading time. That's including job 0 and job 1, which are the training data and test data loading time. And as you can see, actually, Alluxio spent around 369 seconds. When we directly accessing S3, we spend around 579. So we by using Alluxio, combine Analytics Zoo for deep learning, actually, the data loading actually Alluxio can achieve 1.5 times speed up. So in the meantime, we can also see there's a very small standard deviation for both with and without Alluxio. So I think the data number is quite convincing. So yeah, so basically we combine Alluxio and Analytics Zoo. We have a good solution to do the deep learning on a big data cluster. So that's the performance result. So let me give back to Finn for conclusion.
Oh, okay. So, I think like this is the end of the presentation, and I'm here, and all three speakers are here. So in case you have any questions, feel free to put it in the chat box or go to our Slack channel, so you can just always retrieve back the questions. Yeah, we are here and we are online, serving for a few more minutes for any questions. Or in case that we have any questions. So maybe, I don't see any questions so far, but maybe Jennie or Louie, it might be interesting to share a bit, like let's share this in a very informal way. We don't have any slides for this, but talk about maybe the motivation or anything you think that's interesting in developing Analytics Zoo.
The Analytics Zoo, so for the innovations is that I just talked about before. So we noticed that in the big data areas, the people are eager to adapt deep learning models and algorithms to their existing workflows. But there's a big gap between the deep learning community and the big data communities. In the in the deep learning communities, the researchers or the engineers are work on the models and the algorithms, and they use their public or some private data set. And but their goal is to make the model efficient and to get more accuracy or other metrics. But in the big data communities, there's some difference. So they work on their production clusters and the data. And if they want to leverage the deep learning community results, they can maybe move data to some research data clusters. And also for the current deep learning framework like the PyTorch, TensorFlow, they are not very easy to integrate to the distributed big data system like Hadoop for Spark clusters. So that's a purpose for us to create the Analytics Zoo, which will eliminate the gap between these two communities.
I see.
So yeah.
That's very interesting. So basically, you're saying there's a basically this there's a gap between these two community and Analytics Zoo. I saw like your slides basically based on all the collaboration. Analytics Zoo is heavily based on the big data analytics tool chains like a Spark or like Hadoop, right? So that's already very mature, and people know how to run this, and people know how to run this at scale. But people typically use this for analytics, for log processing, but less for deep learning. I see like mostly in the other literatures, people use maybe PyTorch or TensorFlow. But it's interesting that you guys put you put Analytics Zoo using the existing tool chains to solve the new problem in the machine learning space, right? And I think that's a very actually very interesting angle. I assume like a lot of users, they already have pretty well established big data platform, and in that case, they don't have to launch, they don't have to create a totally new cluster, but just leverage whatever they have for the new machine learning problems. I guess that's something can be very interesting and appealing to users.
Yes, you're right. So it's very convenient for the big data users to integrate the deep learning to their existing systems. So as I mentioned in the use case of JD.com, they don't need to do the data transfer or data movings between the different clusters. They just run the deep learning on their existing clusters without using the existing data in the production environment. So that's a very easy way to integrate that.
So in terms of like a DevOps, I know you guys are the developers for Zookeepers, for Analytics Zoo. In terms of like maintaining, operating, and running as a DevOps for the system, do you have any either takeaway or any tips for users?
So,
Or anything special, like a different from running a normal big data analytics platform?
I think for DevOps, what kind of workload they will do, I'm not very sure.
I see. So let me put it another way. For example, in terms of resource provisioning, in terms of like based on our collaboration, I realized the workload can be a little bit different from the typical big data analytics because you have a lot of iterations. The model training is iteration after iteration, right? So this can be very. I feel like this can be different, and that's why a caching layer like Alluxio can really help because you do that's basically the uniqueness about your workloads. You're reading the same data repeatedly, right? It's very easy to get some hot data if you're concentrating on focusing on training models using X amount of machines and for this amount of period of time, right?
Yeah.
That's something different from a traditional big data workloads.
Yeah.
Okay, cool. Let's see if there are any questions from the audience. And by the way, after this session, we will record it and we will make this available. Anytime you can just always go to our website and play back this video. Okay, so we three speakers will stay for a few more minutes. Feel free to hang out, or let's just always hang. You can always go to our Slack channel to talk to us. Oh, actually, Actually, sorry. Actually, we have some questions here. What feedback you have received from users of Analytics Zoo on deployment hints and maintenance? Sorry, I missed the questions on the question chat. I'm still new to this system. I guess this is a question for Jennie.
So, can you repeat the question?
What feedback you have received from users of Analytics Zoo on deployment pains and maintenance? I guess this is on the same line as I asked you on DevOps, something related.
Maintenance.
Deployment and maintenance.
I think Analytics. So to deploy the pipeline, Analytics pipeline, we have the cluster serving service, so you can deploy it to the Yang or Kubernetes clusters. And the feedback from I think we have many users. They already deploy their solution, Alluxio solution, to their production environment, like the Office Depot, Mastercard, etc., and JD.com, and it helps them to improve their productivities, and it's and not only the training but also the inference, and because Alluxio is a unified AI or Alluxio analytics platform, so it can easy to integrate with other ETL workloads or other Spark workloads to construct a complex end-to-end pipelines. So
okay.
So not to just use the Alluxio itself, but you can integrate other workload, ETL or something, and then do the analytics.
Okay, so this is from the user Shubha VJ, like maybe 30 minutes ago. And the next question is from Swastiky. In place of S3, will menu S3 interface should be fine? I guess this is a question for me for Alluxio. So the short answer is yes. We do see users using menu S3 interface to talk to Alluxio. Just, yeah, we think we should have a documentation talking about how to collect Alluxio with the menu. Next question is from Sarah Barv. Are you assuming availability of AWS direct connect to copy data to AWS S3? No, the answer is no. We do not assume any, as long as you have network connection to, well, if you on AWS, as long as you have access to AWS S3, you can already connect Alluxio with S3. Yeah, you don't have to get any specialized service. Next question from Neil Barley. What was the resource, compute, memory, data movement comparison between the with and without Alluxio use cases? Is there additional infrastructure cost? Oh, this is actually a very good question. Because by deploying Alluxio, it brings certain benefits, but definitely it also brings some more complexity. I will say, like, you have a separate system to maintain, to maintain. So that's the OpEx, that's the cost on OpEx. And also, typically what we see, well, in general, yes, running Alluxio requires more additional storage and CPU cost for sure. And if you want to put data in a memory, that means you have to allocate more memory to Alluxio. And this can be a lot of users asking us, oh, I have Spark running already, and Spark is very memory hungry. And how much memory should I allocate to Spark? How much memory I should allocate to Alluxio? It's kind of like a hard question for them. So my short answer to that is, if you have an application like Spark, I would suggest you leave the memory to Spark, but put Alluxio to manage storage resource like a SSDs or a local hard disk. Because if your data is remote, the amount of effort, the amount of benefits you get majority of it already by caching the data local to your compute, compared to further improve this by lifting data from memory from disk to memory. That is marginal. So that's the it's a very interesting observation that if you're running applications, for a lot of times you may only utilize for certain machine learning training jobs, you're only utilizing one type of resource, and typically it's like a lot of GPU or a lot of CPUs. But typically these machines are not running, not utilizing their local disk or local SSDs effectively, and that's actually a great opportunity for Alluxio to manage the resource there, so you don't have to provision extra resource for Alluxio. We did some experiments with some other companies before. We were running a case study, and what they found is a lot of users, they rent their very expensive GPU machines to run machine learning, deep learning workloads. But these GPU machines are typically the very beefy machines. They have a tons of CPUs, a tons of memory, or SSD sometimes equipped, but they are not really utilizing this resource. So if that is the case, putting Alluxio there is not adding extra cost, but it's just like making your existing resource more utilized. So that's the direction I will go to think about your applications and think how we can use existing resource using Alluxio to benefit your applications. Yeah, maybe another angle to this question is about the data movement. If you want to implement data movement, simplest way we see in the field is just to run a distance CP if you're running Hadoop, right? And that requires, that's actually pretty simple. People are telling us this is a very simple thing to run. We don't care about data movement, sure. But later on, what we see typically is they quickly fill whatever they launched in the cloud or closer to the story, closer to the compute soon, and they have to write jobs to clean up the data. So that's the basically intelligence we bring in by using Alluxio. You don't have to manually involve in the data movement. You don't have to manually clean up the data when this storage is filled, right? You can even set intelligent data policies. Set a TTL. I want to stay the data in store the data for 7 days or something like that. And after 7 days, this data will be removed automatically. Yeah, so that's the benefits I will say more on the OpEx, the operating cost side. That can save. Okay, I think we are pretty much the time is pretty much there. So I'm glad to be here to introduce this exciting and a very interesting technical stack using Analytics Zoo with Alluxio. Anything else you want to share from Jennie, from Louie?
So one more thing. So actually, for Analytics Zoo, if you're using Analytics Zoo, you can also leverage all the optimization from Intel. So we support the latest instruction like Intel DL Boost. So yeah, so basically you will get the latest performance optimization also.
Oh, I guess this is one of the reasons. One of the reasons of it is Intel is for example, has a lot of people to back this project, right? So you guys had a lot of optimization based on Intel hardware.
Yes.
Cool. Yeah. Thank you for joining our session today. As I mentioned earlier, our video recording will be available soon, and we will share with you guys. And you can always go back and play back. Meanwhile, we have a Slack channel. You are invited to our Slack channel. Whenever you have any question, feel free to engage with us on the Slack channel. Thank you so much for having you today, and see you next time.